Hello everyone, this is Tutya and I'm going to demo the rack pattern in Spring AI. We have used PostgreSQL for storing our vector embeddings and OpenAI's GPT-4 as the LLM model. In this demo as well, like the last one on MCP, we are going to search for used cars. Along with that, we have a boarding pass that we are going to chat to and also summarize. Now a little bit into what's RAG. Retrieval augmented generation RAG is a pattern where we stuff the LLM with additional context for it to answer accurately. Let's take an example. If I ask the LLM something that it is not trained on, it will hallucinate. Like if I ask, which car do I own? It won't be able to tell that as it is not trained on that data. But if I give it some context, something like in the year 2021, I liked Tata Altroz in terms of its build quality, budget, and other features, so I bought it. Now, if I ask the same question, it'll tell me that I own a Tata Altroz. I'll drop the link to my GitHub code in the description for you to look into the dependencies and other configurations that I've used. And I'll directly jump to the code that I've written. The code is open and this is the first endpoint of prominence for us. It is here where we load the vector store with cars. First, we extract all the cars available in the cars table, then we iterate over it. The content for each car object is converted into a string to create an AI document. Once we have the document list ready, we add it to the vector store. Similarly, we have an endpoint to load the content of our PDF to the vector store. We're using TK document reader to read the PDF and then splitting its content to finally load it into the vector store table. Let's head over to the chat controller. In the chat controller, we have the chat endpoint which accepts user's prompt, which is then passed to the rack service method where we create the augmented prompt to be used by the chat client. Let's look into that method. What we do first is we do a similarity search on the vector using the query the user has passed to get the list of documents, similar documents basically. Once we have that, we join the text content of those documents into one string of information. This is what is the step we refer to as retrieval in the RAG pattern. Now, we are going to use a system prompt template where we attach the information extracted from the documents to create a prompt that is returned to the chat client to use. The chat client will then use that stuffed prompt to call the LLM to give accurate response. With the application starting in the background, let's move our focus to the database now. We're using pgadmin. If we check the cars table, we have 30 used cars here. Vector store table is empty right now, so let's add content to it. We're using this endpoint to load cars data in the vector store. It executed fine, so let's now go ahead and validate this in the DB. You can see that all 30 cars have been added to the vector store table. Each car has a uniquely generated UUID. The car's object is stored as a string in the content column. We are not referring to any metadata, so the metadata column is empty. And finally, the most important thing for us, vector embedding, in which matrices conversion for the content column is stored. If I copy and paste it, you will see that the content in it is huge. It's just huge. Now let's load the PDF to the vector store. We will hit this endpoint, execute it successfully. So let's validate in the vector store. It has 32 entries now. Let's scroll down. You will see that we have two new entries to the vector store. Our PDF has been broken down into two parts or chunks and they are stored. They refer to the same source file, which is the one that we used in the code. And this is the vector embeddings. With the vector store loaded, let's fire a prompt to see what happens. First, I'll clear the logs so that we can see what happens when we fire the prompt. We're going to use the chat controller and the chat endpoint, and I'm going to say something like, find me a Tata car which is red in color and hit the send button. It ended up finding me a car and all its detail. Let's check the log where it will be interesting. First thing that happened was it found similar documents through the vector store similarity search. For this car Nexon, it found the distance from our user's prompt and a score it would give it. It found another car, and this car had a different distance and a different score. Nexon had a different score. It actually found four cars, each one with a different score, and the closest match was returned by the LLM. Time to chat with the boarding pass PDF now. I'm going to ask the LLM to summarize the boarding pass with this PNR. I got the summary from the PDF. It is giving me all the details like passenger name, flight duration, flight number, the airline that will operate the flight, etc. Point to note over here is that we just said summarize it. So it summarized based on the information it thought was important. Let's summarize with the information we need, like seat number, ticket price, and let's get that in the form of a regular Java object. We have this endpoint to do that for us. It requires a PNR. The vector store will be searched for this PNR and will return me the information we have defined in the REST API's response object. As you can see, we got the details like coupon used, ticket price, and other details. Let's check the code for this endpoint. We have this lengthy prompt to get the desired content from the PDF. User will pass the PNR that will be used in the prompt formation. We're also saying that find me this information and map it to this field of the response object. Our response object is the boarding pass summarizer model, and it has these fields. Let's validate the content in the PDF with the response we got. As per the PDF, the flight is on Saturday 28th of June. The summarizer gives the same response. Great. The flight is from Kolkata at 5 and to Mumbai at 8. Matched. Check-in allowed is 15 kg and cabin allowed is 7 kg. This too matched. Let's validate the ticket price. In the PDF, we see the ticket price is 6544 and it says we saved 847 using this coupon. The summarizer response is saying the same thing. Yeah, it is. So we were able to summarize the PDF in two different ways. And that's it for the demo. If you have any questions, please drop a comment. Thank you.